This is the cover screen from the Lesson 6 notes, which you can find in Canvas. So I'm not going to spend any time reading the standards. You can read them yourself. But I do want to come down here to this opening exercise. It says a function is said to be linear if the rule defining the function can be described by a linear equation. So it says it's linear if you can make an equation. Well, the only way you can make an equation is if you have the slope and the initial value. Functions 1, 2, and 3 have table values as shown. Which of these functions appear to be linear? Justify your answers. So I'm going to look at function 1, function 2, and function 3. I'm going to walk us through function 1 together. So I'm going to need two ordered pairs. So I'm going to go with 2, 5, and 4, 7. As always, we want to label our ordered pairs. Draw the model, and then move my values in. So y2 minus y1 over x2 minus x1. 7 minus 5 is 2. 4 minus 2 is 2. Gives me a rate of 1. So if the rate is 1, I can actually have two ways I can go about this. So in this one, I'm going to write the equation. Y equals 1x plus b. So we know that they multiplied by 1. 2 times 1 would be 2, but they got 5, so maybe they added 3. 4 times 1 would be 4, but they got 7. Oh yeah, they added 3. So I'm going to hold here for a second. An equation is said to be linear, a function is said to be linear if you can describe the function with an equation. So far, I know that this row follows the equation, and I know that this row follows the equation. If the next two follow the equation, then we do indeed have a linear function. 5 times 1 would be 5, but they got 8 because they added 3. 8 times 1 would be 8, but they added 3. All right, it is, in fact, linear because the rate was the same throughout. All right, same process here on input-output table 2. I'm going to grab two ordered pairs. So we have 2, 4, and we have 3, 9. Go a little faster through this one. 9. I guess I should label x1, y1, x2, y2. So y2 is 9 minus 4 over 3 minus 2. So that would give me 5 over 1. Y equals 5x. Well, 2 times 5 would be 10, but they got 4. Maybe they subtracted 6. 3 times 5 would be 15, but they got 9. Right, that should be a 15, but they got 9. Oh, they subtracted 6. So far, so good. But let's come down here. 4 times 5 would be 20. If you subtract 6, you will not get 16. Same here, 5 times 5 would be 25. And if you subtract 6, you would not get 25. So this is not linear. In fact, if you look at it closely, and if you've paid attention to the math here, on the right column, those are all the perfect square of the left column. Right? 2 squared is 4, 3 squared is 9. So while it's not linear, this does have an equation to it. It would be x squared. Or I shouldn't even use y, I should say f of x. All right, let's inspect a couple more. All right, I want you to take a minute, pause the video, and read this entire question, parts A and B. All right, this is really the only example we're going to work with here in this lesson. You'll notice I've done some highlighting. So this is a function, blah, blah, blah. Do you suspect it's linear? So you can see I answered that question. I said yes. I don't really have any reason not to suspect that it's linear. And then compute the rate of change for at least 3 pairs of inputs. So I have a pair there, a pair there, and a pair there. So I'm going to pause the video and do my computations. So to wrap up, I found on those red ordered pairs, the top row and the row following it, the slope was -3, And then when I came down to this row, these hot pink here, that was also -3. And then when I looked at the last set, which was these two, I also got -3. So right now my assumption, or my mathematical guess, my estimate is y equals -3x. In fact, let me take that back. I need my function notation. F of x equals -3x. Okay, so if they multiplied by -3, 1 times -3 would be -3, but they got 2. So wondering there, what is my mystery number? Well, let's just add 3 to both sides. 5. Let's prove it on our other equations. 2 times -3 would be -6, but they got -1 because they added 5, and so on. So that's all for this video. If you're looking for some additional practice, you're welcome to pause the video here and work on this worksheet on your own time. But otherwise, you can go ahead and move into your 5.6 homework.